Hello, I'm Tai Xie. Today I want to have a presentation about the hyperparameter tuning in using the Portuguese banking file to find out I like kind of the CV or great machine learning operation optimization. So there are the three plays or three topic I want to talk about to summarize what's going on in my assignment. The first is model performing. I want to make people more understand about what kind of my model, my accuracy is, blah blah blah. And the second one I want to talk about is which parameter I tune and help me to get the great optimization. And third is I want to talk about something what I think is in this assignment. So the first one is model performing. That's the result, the final result. I found it that uh, if we use the random forest like the grid bias or the random search, we can get it highly AUC. So you can see the right picture, we can get AUC got highly than like 0.92. However, the decision tree couldn't get the grade very accurately. Like it's between 0.74 to the 0.83. And in random forest, I found that the research it have a great accurately whatever in the accurately and the F1 score. I think I can talk about the accurately and F1 score. That's something different. Accurately is talk about this model totally that have they what their ability to find out the big range, like the big feature. How can they like to identify which big feature is? However, the F1 score is focused on something like some small range feature. So I think in my model, I can both can get the grade accuracy and F1 score can like to affect that the big range and small range I can do best as well. So how could I do? Because I think the pre-work is very important. And the first one is one hop encoding, and the second one is SMOT. And this two thing we must be do because if we didn't do that, we couldn't like to increase our accuracy. So one hop encoding is transfer the categorical variable into the numerical numerical format, like using the dummy. And these methods create a binary column and making the feature interpretable by the model. And the small is help us to balance our data. Like so, if like our data say, firstly we didn't have the very balanced way, so we can use the small to help us to increase our some small range uh picture was more implemented to help us to like get them balanced and find a great accurately. So like before, I didn't like to adjust above the parameter. We just do the pre-work and I we can finally get the very higher than something previous didn't do anything. Yeah. So second one, I want to say about the hyperparameter tuning and analytics. So at first, I want to talk about the decision tree and random forest. Like I say, decision tree couldn't get the very great like, accurately because they couldn't they couldn't help them to found out some outlier or anything uh, random forest this because like the random forest a decision tree like is the part of the random forest. So if we use the decision tree, we just like can only use one machine to do anything, to do things. But the random forest likes to use a lot of machine to help them to find out what their error or what's the best estimator. So random forest have the great like to help people to to or have the information to get the prediction. Yeah. So I used the three search to help me to find out the great answer. The first one is grid search and random search, and finally is Bayesian optimization. And grid search is help us to like ev evaluate all the parameter combination to find the optimal set. Like the picture say that they were to ordinal to find out some parameter and to make them understand, oh, they can like search all of the parameter in our informations. And the random search is like to help us to combination, like help the random search samples parameters combination within the defined range, saving the time in the large parameter space, and it's useful like to quickly find out the good combination. Quick is the important things, and thus it might like some count thing is might be like miss the exact optimal. And the third one is Bayesian search. And Bayesian search is update based on the past result to predict the next likely optimal parameter. So they can help us to have a great exploration and efficiency and help us to like to do some if we want to do some complicated and large machine learning, I think the by answer search is the great answer for anything like this. So that is my final result. So first, I want to talk about the parameter. And firstly, I do the random forest random. I use the mean sample split in the five, and I found it that if the great uh, search got to the two, they had the great answer of that. And so I adjust this and so I can get the grade accurately. And estimator, first I like the right coding say that and the range, the integrated range on I set it on the 50 to the 200. And finally, I felt that 100 is the bad thing is because I used the best estimator to help me to find out the different random forest model can find out which is the great estimator. So I found that is the 100 parameter and helped me to get like the over the 0.9 F1 score. So I think firstly, I can get the balanced data using the one hub and using the Smooth. And finally, I use the great machine learning model and great hyperparameter tuning to help me get this great higher rank. So in this time, I think it's probably different in the last assignment because I can truly understand in the operation of the different model, and they can help me to like to turn in my high per matter. And not only that, but also apply like to learn how to apply like the one hops encoding and small. They can help me like probably like to cleaning our data and make our data uh, become what we want to use. And that finally things is we can set in the overlay world and parameter range can like lead to the overfitting. Overfitting, yeah. Overfitting is a very important thing in the machine learning. We need to avoid of that. Even we can get to, like the great machine learning accurately at first, we must be like to find out a whether they have the overfitting problem or not, because it will like if we want to do some like the deep learning things, it will affect about like one machine have some problem, and if we deep learning like to combine with all of the one machine, so they will like have a very complicated problem in the future. So yeah, that's my presentation. Hope you guys like it. Thank you.